This next section is about the equation of straight lines and about their intercepts. You should remember from the past that the equation of a straight line is given as y equals mx plus c. We also have a new way of writing equations of straight lines, and that's in this form, ax plus by plus c. So in the y equals mx plus c one, we know that m is the gradient, c is the y-intercept. So we've got those two components going straight into the equation. For this one, a, b, and c are just constants. We use these when we want them to be integers. So to avoid having fractions in this form, we change them all into integers, and we have it in this form. So this is what y equals mx plus c looks like. In order to avoid having fractions now, we would double everything. And we tend to always write it equal to 0 with the x term positive. So we'd subtract the 2y here, giving us x minus 2y plus 3 equals 0. Similarly, we could rearrange one from this form into the y equals mx plus c form if we're looking for the gradient. So we would add 2y and divide by 2. So that we've then found the gradient and the y-intercept for this line. So we have a bunch of lines here. So if you just pause the video and see if you can remember how to write down the equations for all these lines. So the light blue line is going straight across. It's got 0 gradient. We just say the light blue line is y equals 3 because it's just going through 3 on the y-axis. With the blue line, for every 1 across, it's only going a half up. So the gradient is a half. And the y-intercept is 0. So we don't have anything on the end. So we can either leave it in that form, or we could say could say 2y equals x, or in the form we like, we'd say x minus 2y equals 0. The black line, for every 1 across, it's going 2 up, so the gradient is 2. And the y-intercept is 3. Red line, if we start there, we can see that for every 1 across, we go 3 up. So for the red line, we've got y equals 3x, and a y-intercept here of minus 2. This brown line is vertical, it's going through 4 on the x-axis. So this x equals 4. And then we've got the two negative ones. So remember, if it's going down, it's got a negative gradient. The green line, for every 1 across, it's going down 4. So green line, we've got y equals minus 4x and a y-intercept of minus 3. And finally, the purple line, for every 1 across, it's going down 1. So y equals negative x and a y-intercept down at minus 4. Okay, so we need a strategy for finding the intercepts in order to get our equations. So just remember, in order to find where they're crossing the axes, if we're looking for where it's crossing the x-axis, that's occurring where y equals 0. And if we're looking for where it's crossing the y-axis, that's occurring where x equals 0. So in order to find our x-intercepts, we can substitute 0 for y. And if we're looking for our y-intercepts, we substitute 0 for x. Okay, so we're going to do that now for these ones. So for this one, we can see we've got a gradient of 8. Straight away, we've got our y-intercept, minus 4. 0 minus 4. And then if we're looking for the x-intercepts, we'd have to say that y equals 0. And then we'd solve this equation. 8x equals 4. So x equals a half. So our x-intercept is a half. 0. Similarly here, we've straight away got our gradient. It's negative a half, because it's the coefficient of x in y equals mx plus c. Negative a half. Our y-intercept is already in the form y equals mx plus c, so this is our y-intercept. And for the x-intercepts, we have to solve this equation. So x over 2 equals 5. X equals 10. So x-intercepts is 10, 0. Now, when it's not in the form y equals mx plus c, there's a little bit more work to do. As I said before, if we want to find the gradient, we need to rearrange it so it is in that form. So we would simply subtract 2x here. We've got our gradient. Minus 2. We now see our y-intercept is at 8. And then for the x-intercept, we're solving when is y 0, so we can just put y equals 0 into the original equation. So we get 2x plus 0 equals 8. So x equals 4. So x-intercept 4, 0. For this one, we just need to expand the brackets to get it in the form we want. So expanding, we get 6x plus 4. Straight away, we see our gradient of 6. Our y-intercept must be 0, 4. And for the x-intercept, we're solving 6x plus 4 equals 0. So 6x equals negative 4. X equals negative 2/3. So x-intercept of negative 2/3, 0. And the last one is in the other form, so we need to rearrange this to see it as we want it. Giving us our gradient. Our y-intercept. And we just need to solve this equation to find our x-intercept. 3x equals 10, so x equals 10 thirds. X-intercept 10 thirds, 0. Okay, if you can now do the same thing for these ones, so for each one, find the gradient and the intercepts, x-intercept and y-intercepts. Now once you've finished those, you can use this exercise as your practice.